So let's continue. Again, we're still in radian mode. We're in 3.3. We're talking circular functions, and we're still doing some old and new things. The old thing we're doing or redoing is the idea of, can I tell you whether I'm going to be positive or negative? Yes, you can just throw this in your calculator and come up with the answer. I get it. But to develop a good understanding of what's going on, can you explain yourself, right, with what's happening with our new definitions? And so this was pretty easy to do with x, y, r definitions, right? We knew when x is negative, we knew when y is negative, r was always positive. But how do we do this in circular functions? Well, what you're going to have to do is remember what this means, right? So first of all, notice there's no degree symbol. So that's another dead giveaway that we are in radian mode, all right? And so be careful too on your homework. If you guys start dropping that degree sign, I'm going to assume you're in radian mode, and you're probably going to get a lot of things wrong. So since none of these angles, or these arc lengths, if you would, don't have any little degree symbols, we are definitely in radian mode. And so what does sine 3 look like? What does 3 radians look like? Well, if you remember from our sketches, 3 radians, right, roughly took us on a unit circle, right? That was about 1 radian, 2 radians, and 3 radians, right? So there was 1, 2, and 3 radians. You want to draw an angle or think in terms of arc length, you can do both, right? Because theta and s are equal to each other in the unit circle. And so that basically tells us that we are in quad number 2. And what do we know about sine in quad number 2? Well, we know that it's negative. All right, so that's how you could effectively argue it, all right, without having to go to your calculator. What about the cosine of -1? Well, because it's negative, that means we're now rotating, right? If I drew a picture of this unit circle, we're now rotating this way. And if 1 radian was about 60 degrees this way, then -1 radians is about that much that way, all right? And so we're basically in quad number 4. And what do we know about the cosine, the x values, if you would, in quad 4? We know that they're positive. So the cosine of -1 would have to be positive. Tangent of 4.25, well, I already know what rad 3 is. So 4 radians, right, 4.25 radians would definitely take us, right, somewhere, right, into quad number 3. Okay, and in this quadrant, we know that tangent, because x and y are negatives, right, we know that tangent is positive. So that's basically how I can answer that, by just remembering what a radian is and coming up with a sketch, figuring out which quadrant we're in, and then kind of relying on our old definitions with x, y's, and r's. Of course, I can turn to technology, right? Hopefully you guys can see that. My TI-84 is still a little under the blitz, but here's just my cell phone. And so when I basically calculate the, when I calculate the sine of 3, right, what I get is what there's the actual value. It's 0.144. Oops, yeah, I guess I better listen to myself, right? The y value up here is positive. Oops, there's the technology helping me out. You guys are probably screaming at me a few minutes ago that, right? Yeah, so up in this quadrant number 2, y is positive, so sine's positive. And there's the technology basically correcting me, so sorry about that. Good thing I turned to technology. The cosine, right, of -1. So let me come back here, right? We're talking negative, oops, cosine, I got to get my TI calculator back, right? -1, and let me close those parentheses and press equals, right? And what we get is a positive value. We're expecting a positive value. And then the last but not least, the tangent of 4.25, right? Let me close those and set it equal. And what we get is a nice positive value. So sorry about that. I screwed that up. I had a nice picture, had the right quadrant, and I just said the wrong thing. And then the technology kind of helped me out. All right, so that's how you would argue that with that. And of course, how do we do the next round, right? Now that I've brought in the technology, how do we do that? Same thing, right? So you just saw me. So sine of 41. Let me clear that out. Let me bring up, make sure you're in radian mode, right? The sine, and oops, I don't need to double. Clear that. Sine of 4.1, and again, that's in we're talking about 4.1 radians, arc lengths along, and when I press equals, right, we're roughly, it's a negative 0.81, look, 8 and 3, right? So there's basically how you would calculate that with your calculator. Cosine of 0.75, so again, using my calculator here, I got cosine, and I have 0.75, so we're 3/4 of a rad, so we're not even going 1 radian, we're just 3/4 of it, and pressing equals, and it looks like we are 0.7317, and so forth and so on. Tangent, right, the tangent of 2.5 radians, so we're 2.5 arc lengths along the edge, and what we get is a value of negative 7.7470, and on and on. Cosecant, again, you'll notice on the TI and on my calculators there's no cosecant, so we first have to say, well, this is actually 1 divided by the sine of negative 5.25. And so for me, what I would basically do to calculate this is basically say I'm in radian mode. Let me clear that. I've got 1, and I'm dividing that by the sine of negative 5.25. And let me close those parentheses, hit the equal sign, and it looks like 1642. So 1.1642. Secant of 6, well, that's basically 1 over the cosine of 6. So I'll come back to my handy-dandy calculator, say 1 divided by, and the cosine of, not that. Lost that. Cosine of 6, right, and that equals, looks like 0.0415. So 1.0415. Of course, cotangent, well, that's 1 over the tangent of negative 1.773. So I'll come to my calculator, type in 1 divided by the tangent of negative 1.773. Close those parentheses, hit equals, and that looks like it's roughly 0.2050. Okay, so same stuff, we're just in radian mode basically. So make sure, again, tell me what you're inputting in your calculator, make sure you're in radian mode, and in this case I was rounding off to 4 decimals. So let me go ahead, this is already getting a little lengthy, I'm worried about time, so I'll do the next section on my little calculator in another video coming soon.